So let's now start on the topic of vector algebra. In this video, we'll take a look at the quantity or concept of vectors. There are two types of quantities. You have scalars and vectors. Scalar quantities are quantities that have magnitude. So that's basically amount and unit. Examples of scalars: length, distance, speed, time, mass, energy, and temperature. Scalar quantities only have magnitude, amount, and unit. For instance, you have a bust that is 5 meters from the origin. Distance x is 5 meters. You have amount 5 and you have the unit meters. So distance, being a scalar quantity, only has magnitude. On the other hand, vector quantities not only have magnitude, but they also have direction. They have that additional information, direction. Examples of vector quantities include position, displacement, velocity, acceleration, force, momentum, energy change, and temperature change. For instance, position, you have the same object, same distance from the origin, 5 meters from the origin. But so that gives you the magnitude of the position, x is equal to 5 meters. If we now take into account the direction, you have angle 35 degrees above the positive x direction or positive x line. The position of the object becomes 5 meters magnitude and the direction is 35 degrees above positive x. Position, being a vector quantity, has magnitude and direction. 5 meters, 35 degrees above positive x. When doing analysis or calculations with scalar quantities, you can use your normal algebra, in doing addition, subtraction, multiplication, and division. Just bear in mind that when it comes to addition and subtraction of quantities, the quantities must have unit. So they must be the same type of quantity. So if one is distance, all the other quantities must also be distances for you to add them together. And again, they must have the same unit. The same applies for vector quantities. When performing addition or subtraction of vector quantities, they must have the same unit. In addition to that, normal algebra is not enough to handle vector quantities because vectors have that additional information, direction. When you do vector analysis, you have to take into account the direction of the vector quantities. That's where vector algebra comes in. Displacement is change in position, and you'll recall displacement is a vector quantity. It has magnitude and direction. Suppose that the bust moves from point A to point B, displacement XAB, and then from there the bust moves to point C, displacement XBC. the resulting displacement as the object goes from point A to B to C, the resulting displacement is XAC. This tells us that XAC is equal to XAB plus XBC. The vector, the resultant displacement, the vector XAC is referred to as the vector sum or resultant vector. If the bust travels from A to C and then from C to point B, the bust undergoes displacement XAC and then XCB. The total displacement, the total change in position of the bust is XAB. So just like in the previous situation, the resultant displacement XAB is equal to the sum of the individual displacements that the object underwent. So from A to C, XAC plus from C to B, XCB, XAB is equal to XAC plus XCB. If we go to the previous situation, XAC is equal to XAB plus XBC. XAB is equal to XAC plus XCB. So if we isolate XAC in this second equation, XAB is equal to XAC minus XBC. XAB, XAB, this implies that XAC minus XBC is just equal to XAC plus XCB. Telling us that XCB is equal to negative XBC. XCB from C to B is just negative of XBC displacement from point B to point C. If you compare the two vectors, XBC and XCB, the only difference between them is the direction. XCB is from C to B, XBC is from B to C. They have opposite direction. Same magnitude, but opposite in direction. The negative sign implies that the direction has been reversed. The negative of a vector is a vector with the same magnitude but opposite direction. And as we can see here, XAB is equal to XAC minus XBC. We can rewrite this equation as XAB is equal to XAC plus negative of XBC. Vector addition with negative of a vector applied, that's vector subtraction. So if you know how to do vector addition, you also know how to do vector subtraction technically. All you need to do is apply negative of a vector. Vector addition follows both the commutative and associative laws. A plus B, vector A plus vector B is equal to B plus A plus B plus C is just equal to A plus B plus C. The order in which we add the vectors does not really matter. A plus B plus C is equal to B plus C plus A is equal to C plus A plus B. Knowing this may make your analysis of a system, analysis of a problem easier. The problem might give you the vectors in this particular order, but if you are adding the vectors together, you can order the addition in any way, and that might make the analysis easier. So please take note of this, not only of the commutative and associative laws. Take note that the order in which you add the vectors does not really matter. And that's it for our discussion for this video. In the next video, we'll take a look at how the directions of vectors are described. Very important that you know how to describe the direction of a vector. It's because it's the direction of the vector that needs to be taken into account when you do vector analysis. That's why you are not able to apply ordinary algebra that you studied in your basic mathematics. The basic addition, basic subtraction, basic multiplication, and basic division of quantities. You are not able to do that with vectors because of the direction information that the vector contains. So it's very important that you need to know how to describe the direction of vector quantities. And that's what we'll take a look what we'll take a look at in the next video. So thank you for watching.